Hello everyone. So I welcome you all of you in this series of lecture under the section of sequence and series. So we are going to learn about summation of series here. Okay. So today we are going to discuss about sigma functions and what is sigma and what is the use of sigma here. Okay. So let's start. See, I already know about some basic sums. If we have 1 plus of 2 plus of 3 up to 4 up to if I add up to n number, then in this place I can write simply summation of r. Okay, where this r is vary from 1 to n. Okay, so here this summation is known as sigma. Okay, so this summation is known as sigma. Okay, so here what is the meaning of this r equal to 1 to n? It means if r equal to 1, then 1 is here, and the rule of this sigma is put the plus sign here, then the value of r will increase and it become 2. Then the again we have 2 here because r is here. Then the role of the sigma is put plus sign here, and in this way we have numbers and then plus my plus sign. Okay, so at last here we have n. Okay, so we are going to learn about some basic sigma. Suppose that we have sigma, and then this number is from 1 to n. Here this number is considered as lower limit, and this limit is known as upper limit of this summation. Okay, so the summation is considered as summation with limit. So if we have 1 here, okay, so if I add 1, then because r is vary from 1 to n, then plus sign will be there. So here we have to add 1 up to n times. Okay, if I add 1 n times, then here we get n. Okay, now let's take r equal to 0 to n, and 1 is there. Okay, so if counting start from the 0, then if counting is 0, then we have 1. Again counting is become 1, then here we have 1, and this process will be repeated up to n plus of 1 times. Okay, so here we have n plus of 1. Similarly, if we have r equal to 0 to n, but here we have r. So as we know, first number will be 0 because the 0 is here. Then we have 1, 2, and in this way, here we have n. So again, the sum will remain same 1 to n. Okay, and in first here also we have the sum 1 to n. So I can write this summation in this way from 1 to n, but summation remain the same. Okay, see, if we have some other summation like r equal to 0 to n, but here we have some another number like k is there. Okay, so k is treated as constant because r is not there. Okay, so I can take this k common from this solution. So I can write this sometimes and plus all. Okay, is this clear to everyone? So now I'm taking another value. Suppose if we have a of and b of have n. Okay, so because I is there, it means the I term should be variable and b of b is considered as constant because if I change the value of I, then b of b is constant. So I can take common b of this function, and here this this way. See, here, then here, and up to a of n is there. Take one more example. Let's suppose if I have summation of I is there, and if I take I equal to 1 to n, then it is nothing but 1 plus of arithmetic mean. If I add distance from the then the solution will remain constant. And if here we have n terms, then n is there. And if I add first term and last term, then this will be I obtain. Okay. So from here n and n plus 1 by 2 is this term. And I can write this term in this way also. This here, if it is not mentioned here, then I considered R is from R is from R equal to 1 to n. Okay, so R is nothing but n plus 1 by 2, where n is the last term. Nth term. If we have solution of R square, equal to vary from 1 to n, and here we have I square. So solution of this term is equal to n plus of 1 and n plus of 1 divided by 6. So this is the formula for summation of R square. One more formula is there is summation of R cube, which is equal to I equal to 1 to n. And if R square R cube is there, so this is n plus 1 by 2 whole square. Reduce this formula, then you will watch my another lecture where I can prove all these three formulas. Okay. So now we are going to solve and which is based on this three solutions. Suppose we have nth term. Okay. Then I want to calculate the sum. So here we have some nth term. Let's write down the question. Nth term. Find sum. Here we have some another term. Let's suppose if we have a of n which is equal to 3n square minus of n is there. So I have to calculate the sum of this. If nth term is given, then I can write a of r, rth term is like that. 3r square minus of r is there. Okay. So for finding the sum of n term, I can take the summation of r. Here we have the summation of 3r square minus of. I can take this for 3 common from the summation. Then here we have summation of r square minus of summation of r. And I already know about this summation, which is equal to n plus of 1 and 2n plus of 2n plus of divided by 6 is there. And here we have n times n plus this term with this. I can take common from n plus 2 and n plus 2. And here we have 2n plus minus 8. That n square is there and n plus 1 is there. It is the sum of this and another term. So another term, then I can use the same method to solve this question. Similarly, suppose if we have a of n is equal to 3 raised to the power n minus 2 raised. If we have then from here, if I replace n with r, then I get the rth term. So this is the rth term. And for summation, I can write summation of 3 raised to the power r minus summation of 2 raised to the change the value of here we get 3 square 3 cube. Already here we have 2 square 2. Here we have some solutions. What is the sum of if a s of n is equal to a r to the power n minus 1 divided by r minus of. So I'm going to apply the formula of GP. So here we have 3, then 3 raised to the power n minus 1 divided by 3 minus of 1. And if we minus of 1 minus the power n minus 1 times. I can simplify this term. Then let's say this is the, then I can find the solution. If from this table. Okay, let's take another example where we have some equation series. Okay, so let's take another example. If I take a series and just write down find the given series. Here we have the sum. S is equal to 1 is here, 3 square is here. Similarly, 3 into 5 square is there. And similarly, 5 into 7 square is there. And so on. So this is the solution. Going to nth term. What is the nth term? Okay. Finding the nth term, I have to take the idea from these terms. Okay. There must be some pattern. So if we have nth term, see here, second term we are taking, again we have 5. It means odd number is there. I can write odd number in such a way that 2n minus of 1. If I take the value of n, then 1 is there. So what is the difference between these two numbers? I think 2 is the difference. So here I can write 2n. If I this term, then a plus b and a minus b is there. So 2n whole square minus 1 I can write. And I multiply this term is 2n plus 1. Okay. So from here, if I write this term, see, this is 2n whole square, it means 4n square. If I multiply these two terms, then 8 of n here plus of square is there minus of 2 and minus of 3. So here we have the of n or p of n. S of n you have, which is equal to summation of t. It means this is 8 n square minus right times we have 8, and this one is nothing but n plus 1 divided by 2 4 have n plus 1 2n plus 5 plus 2 times of n square. Can I take anything? One term second term will form. So if I multiply here, this term will form, and from here, 4. Let's see if we have this one. Okay. This term and data is 2 plus this R is 1, then R equal to 2, then 7. I get this is write this here to here, here, right? We have 31 whole square plus 32. Okay, so what we are going to do, find the sum of 31 square, 32 square, and similarly we have. So one method is just find another term and then solve. Another method I can solve here. And can you see here? If you have it means in R R will be there. So one is R, other one is R plus 2. Let me see here. And then I just divide it. We have 2 plus 3. Here we have 3. And if I take this, can I write this term as this divided by 6? Sorry, T and plus 6. Now, if theory is clear to everyone, let's take the sum of series. And we have the series in this and 1 minus 1. I write the summation of series term in this way. So C, if I want to calculate the R in the term, yes, I can do it. In R in the term, R minus R. We have TR, then I can find the yeah,